Okay, so today we're going to go over some of the answers to situations 1, 2, and 3, and then I'm going to give you an additional situation, situation number 4, in which I'd like you to try your best to figure out. So this is situation number 1, and as I say, in situation number 1, both person A and person B are clones, so they have the exact same mass. Okay. Of 50 kilograms. So again, we have to go back to the definition of pressure. So once the first part of the definition of pressure is that we have a force. Well, we have a force on both sides, but let's focus on side A for a second. We have a 50 kilogram force going down. Okay. Then the next part of the definition of pressure is at a surface area. Okay, so the surface area, of course, is, well, it's this platform right here, but it's also against these sides of the system right here. And we know that the third part of the definition of pressure is at a 90-degree angle, and you can see that it's 90 degrees to there, 90 degrees to the side. And the last part of the definition of pressure is that it's the force is equal everywhere. So that means that for every square meter in this system, there is 50 kilograms of force being applied to it. So that means that 50 kilograms is being applied to this meter squared, that 50 kilograms is being applied to this meter squared, this meter squared, this meter squared, this meter squared, and this platform here is 2 meters squared. So we have 50 kilograms of force pushing up on this square meter, and an additional 50 kilograms of force pushing up on this square meter. So what is going to happen is that person A is going to travel down, and person B is going to be pushed up, because person B has a mass of 50 kilograms, but we have 50 kilograms of force being pushed up here and an additional 50 kilograms of force being pushed up there. And thus, in total, we have 100 kilograms of force. And we only needed 50, so person B is going to travel upwards. Okay, on to situation number 2. Situation number 2 is essentially almost identical to situation number 1, except that person B now has a mass of 100 kilograms. So basically, person B has double the mass of person A, who's only got a mass of 50 kilograms still. So we want to figure out what's going to happen. Well, again, if we remember, we have a force, and the force is pushing this way, pushing down, and the force is at a surface area at a 90-degree angle at all points in the system, equal at all points in the system. So that means that it's equal this 50 kilograms of force pushing up against that meter squared, against that meter squared, against that meter squared, against this meter squared, and against this meter squared. And so as we have 50 kilograms here and an additional 50 kilograms there, we have a total of an upward force of 100 kilograms. However, we also have a person that has a mass of 100 kilograms that's pushing down. So we have an equal force pushing up as we have pushing down. And what we end up with this situation is a balanced force. And we know that when we have a balanced force going in opposite directions, so this way and that way, we have no movement, and therefore no work is happening. So in this situation, situation number 2, nothing would happen. The platforms would stay exactly where they are, and neither A nor B would move. In situation number 3, we change things up a bit. We have on side a person with 40 kilograms of mass pushing down on a platform that's 0.5 meters. And on the other side, we have a 1,200 kilogram car that's pushing down on a platform that, well, we don't know. And so the question was, what is the minimum size that the surface area must be? So what's the minimum size this platform must be in order for work to happen? Now I'm going to cheat for a second, and I'll tell you why. It's because it's easy, and then I'm going to correct myself in a little bit. So we have side A and then side B. And if we consider that side A equals side B, that will help us come up with the answer. So if we have side A, so on side A, we have 40 kilograms per 0.5 meters squared. Okay, so 40 kilograms per 0.5 meters squared. And we say that that equals 1,200 kilograms over question mark. Well, now we have two equivalent fractions, and we can solve it several ways. I don't really care which way you solve it. I like to use diagrams or visuals, and basically I say, because side A and side B are equal, I know that 40 kilograms goes into 1,200 kilograms 30 times. And so if I multiply the 40 by 30, I get 1,200 kilograms. So if whatever you do to the top, you must do to the bottom. So if I multiply the bottom by 30, 0.5 or half of 30 is 15 meters squared. So the answer, or the lie, is that this platform is 15 meters squared. However, if we do this, we have a balance of force because of this equal sign, which was the lie I was telling you about. So it can't be 15 meters squared. It's got to be anything greater than 15 meters squared. So by anything greater, it could be 15.1, it could be 15.01, 15.00000001, whatever it is. It doesn't matter as long as it's more than 15. And that is the answer to this question. So the answer for side B, in order for work to happen, side B must have a platform of greater than 15 meters squared. This is the last of the situations for hydraulics. So basically what we've done is this is basically the answer to situation number 3, where we have a 40 kilogram person standing on a 0.5 meter platform, and this person is going to cause work to happen to a 1,200 kilogram car who's standing on a platform that's greater than 15 meters. So situation number 4 is, how far down must person A travel to lift the car 2 meters exactly? So how far down must this person travel in order to lift this car up 2 meters? That's situation number 4. Please do your best and submit your answers to me on email. Thank you.